Here's the shocking part first. In 2025, researchers started noticing something nobody expected. Developers who spent months working almost entirely by prompting AI to write their code, what's now called vibe coding, weren't getting smarter at programming. In some measurable ways, they were getting worse at the exact skill that used to define a good developer. Not because AI writes bad code, because the human brain, when you stop making it struggle, quietly stops building the thing that struggle was training. Today, we're breaking down what vibe coding is actually doing to your brain and why the tool that makes coding effortless might be quietly costing you the one skill that made you valuable in the first place. Let's define the reveal clearly. Vibe coding means describing what you want in plain English, letting an AI model generate the code, and mostly reviewing and approving output instead of writing logic line by line yourself. It feels like a superpower, and in a lot of ways, it is one. But your brain doesn't know the difference between I don't need this skill anymore and I never had to build it in the first place. It just responds to what you repeatedly ask it to do. And lately, what most vibe coders are repeatedly asking their brain to do is judge, not construct. To understand why that matters, go back to what we know about traditional coding. Earlier, we talked about the multiple demand network, the brain system responsible for general problem solving, math, planning, logic. Think of it like a Swiss Army knife inside your skull. Whatever the problem is, tracing a bug, planning an algorithm, holding 5 variables in your head at once, this one tool gets pulled out and put to work. Traditional coding exercises that knife constantly, every line you write by hand forces the multiple demand network to actively construct a solution from nothing. Vibe coding changes which tool gets used. When you're mostly reading AI generated code and deciding whether it looks right, you're leaning on a completely different mental process. Pattern recognition and evaluation, not construction. It's the difference between building a house with your own hands and walking through a finished house deciding if the wiring looks safe. Both require skill, but only one of them trains you to actually run the wires yourself. Here's where the research gets uncomfortable. A study out of MIT's Media Lab in 2025 measured brain activity in people writing essays with heavy AI assistance versus writing entirely on their own. The AI-assisted group showed weaker neural connectivity in regions tied to memory and original idea generation, and many of them, when asked afterward to recall or explain what they'd just written, struggled to do it in their own words. Researchers in adjacent fields studying AI-assisted coding have found early signs of the same pattern. Developers who lean heavily on AI-generated code report high output speed, but when tested later without the tool, show slower manual debugging and weaker recall of how their own codebase actually works. That's a twist most people don't expect. You'd assume using a smarter tool makes you smarter by association. What's actually happening is closer to what happens when you rely on GPS for every drive. You get where you're going faster and with less stress, but ask yourself to navigate the same route from memory a month later and the mental map was never built. The multiple demand network only gets trained by the specific act of constructing a solution under difficulty. Skip the difficulty and the training skips with it. But here's the part that keeps this from being a simple AI bad story, because the research doesn't actually say that, and neither should we. The same MIT researchers found something important. The negative effects were strongest specifically among people using AI to skip thinking entirely, generating output with almost no engagement with the reasoning behind it. When people used AI more like a collaborator, generating a first draft or solution, then actively questioning it, rewriting parts, tracing through the logic to understand why it worked, the negative patterns mostly disappeared. The tool wasn't the problem. Passive use of the tool was. This connects to something we talked about with traditional coding. The idea of decomposition, breaking a big problem into smaller solvable steps. Vibe coding doesn't have to eliminate that skill. It can actually be used to practice a different, arguably harder version of it. Instead of decomposing a problem into steps you personally execute, you're forced to decompose it into steps precise enough that an AI can execute them correctly. That's a real cognitive skill. It's just a different one. Prompt engineering, when done well, requires you to specify assumptions, edge cases, and constraints explicitly. Things a human collaborator might infer, but a language model won't. Done badly, it just means describing something vaguely and hoping the output happens to work. So, which kind of vibe coder are you actually becoming? There's a simple test researchers point to, and it's the same one that separates a chess player who's actually learning from one who's memorizing openings without understanding why they work. Can you explain, without looking, Why the code the AI generated actually solves the problem? If you can walk through the logic yourself, trace the variables, predict what would break it, then vibe coding is functioning as a collaborator and your brain is still doing real work alongside it. If you genuinely can't explain what your own code does 5 minutes after accepting it, that's not a productivity win. That's outsourcing the exact mental construction that used to build expertise in the first place. There's also a physical piece worth mentioning, the same neuroplasticity we talked about before, the brain's ability to reorganize itself through repeated effort. Neuroplasticity doesn't care about your output. It responds to what your brain actually had to do, not what got produced. 100 pull requests approved without deep engagement builds far less neural infrastructure than 10 problems you struggled through and solved yourself. Quantity of code shipped was never the thing training your brain. Difficulty engaged with was. This raises an uncomfortable question for the industry, not just individual developers. If an entire generation of programmers learns primarily by reviewing AI output instead of struggling through construction, do we end up with more people who can approve code but fewer people who can debug something truly novel when the AI itself gets stuck? Early evidence suggests this gap is already showing up. AI models are excellent at generating code that resembles patterns they've seen before. They're far weaker at genuinely novel problems nobody has solved yet, which means the humans overseeing these systems need exactly the deep, hard-won pattern library that passive vibe coding fails to build. So here's the truth all of this points to. Vibe coding isn't inherently making your brain weaker, and it isn't secretly making you smarter either. It's neutral. It amplifies whatever relationship you already have with difficulty. Use it to skip the struggle entirely, and you skip the training that struggle provides. Use it to accelerate the struggle, generating a starting point, then actually wrestling with why it works, tracing the logic, rewriting the weak parts, and you get the speed of AI plus the actual cognitive workout that built expert programmers in the first place. The old advantage in coding was years of typing practice. The new advantage might be something stranger, the discipline to stay curious about code you didn't have to write. Are you someone who reads every line an AI gives you, or someone who just hits accept? Be honest. Drop it in the comments.